it does seem like the attendee list has slowed its growth, and we're coming up on 5 minutes after. So I'll drop the link in again one more time to the chat. If you've just joined and want to add yourself or take some notes, there's a link. I will be sharing this and kind of just moderating time and trying to take some notes, but everyone's welcome to take notes as well. There. Oh, bless you, Elliot.
Bless you.
I don't have the permissions to share. I can email slides, but I kind of actually went through the hassle of adding my presentation notebook to the meeting. So if you would be so kind to add sharing permissions.
Do we want to start with the sort of traditional standing items around intros,
Yes,
welcome,
we do.
community outreach, etc.?
Yep. So Hank, your presentation will come up in a few minutes, not just yet.
Not a problem, just highlighting that I don't have the permission yet.
I will grant it at that time. Yep. So hello to everyone new. I do see a bunch of new faces here. We usually go around the room and invite anyone to do intros. If it's your first or second time joining the call, you don't have to speak up, but we would love to hear from you and get to know you a bit. Ed and I and Nell are sort of some of the regulars here, Frederick as well, and then a bunch of other folks who've become part of our merry band. But if you're new, and I'll start by picking on Hank, because I know Hank and I'm comfortable doing that. Hank, would you tell us all a little bit about yourself and what you work on and why you're here?
So I'm a hybrid beast. So hi, I'm Hank. I'm located at Germany. I'm working for several research institutes. Some of them associated with secure information technology, like my Fraunhofer presentation I'm doing today. I'm basically doing the good work of volunteering with SDOs. Two of them are the IETF, which I'm sharing and co-chairing in 2 working groups. And the other one is, for example, the Trusted Computer Group, where I'm chairing yet another working group. And so my basic duty is to align terminology, which is a never-ending recursive task of misery. so because people invent new terms all day and then they won't match, and so for interoperability and standardization, we need things to align. So information models and architectures and alignment of terminology is, as I think, why I'm here. And yeah, so that's one of my tasks.
Awesome. Thank you for the intro and for being here. Anyone else who's a recent joiner on this meeting series? We'd love to hear from you. Just put your hand up or just speak up if you want to. Wayne, I see your hand.
Hi, Wayne Beaton. I'm with the Eclipse Foundation. Ed communicated with us an embarrassingly long time ago, actually, about this, and it's taken me this long to get my schedule to the point where I can start attending. And my colleague Sean Kilpatrick is on here with me as well. I'll let him talk more about himself. We think this is important work and are excited to be part of it.
Wayne, is that a Miss Saigon poster behind you?
It's curious you should bring that up after I mentioned Sean. So in Sean's previous life, he was a member of the cast of the Toronto show of Miss Saigon.
Oh, that's amazing. I was a theater major, Sean. We'll have to connect at some point.
I'll let him decide how much more of the story he wants to choose.
Look where I am now.
Look where I am. Yep.
So Ava, does this technically count as community drama?
Sure, why not?
Anyway.
Yeah, so hi everyone, I'm Sean. I work at the Eclipse Foundation with Wayne. I'm one of our intellectual property analysts, and I work on license and copyright compliance for our Eclipse projects.
Awesome. Glad to have you both here.
And for those of you who are unfamiliar, the Eclipse Foundation is renowned for having some of the best intellectual property hygiene ever.
Damn straight.
Hygiene.
Yeah.
The thing
Fantastic.
that you're doing when you're overdoing hygiene, you are tampering with the immune system, right? So.
And we're all fabulous singers as well.
Oh, today I learned.
Take it, Wayne.
Take it where?
I see another face that I'm familiar with. Eric, welcome.
Hello. Hi, Eric Voigt. I'm here for rats. I'm here to keep Hank honest, which is a very daunting task. And I also know a lot of the people at Cisco here as well.
Cool. Anybody else on the call for the first time or second and want to do an intro? Okay. Ed usually has the next agenda item. Ed, do you want to take that away?
Yeah, let me share real quickly.
Yeah, sharing should be turned on now.
So there we go, GitBOM community. Let me pull the size down so the font is a reasonable size for folks. So the next item up is we have build tool community outreach. We have a sheet where we're tracking folks who are reaching out to various communities because we do have, part and parcel for this is we'd like to actually get GitBOM, because it's so small and simple, into all the things. And so we have a place where various folks have been listing out the communities that they have some contacts with. I would actually strongly encourage someone to replace me on the Eclipse line here. So I can put you down here, Wayne. Okay, excellent. And you are still supportive. Awesome. But basically, this is just a time to sort of get folks who are interested to either add communities they think we should be reaching out to, and or add folks that they have contacts and are reaching out to.
I should note JavaScript on there. As we've been chatting a little bit with some of the NPM folks who are at the Microsoft GitHub boundary.
Oh, fantastic. I've been chatting with some people from a different direction. We should probably talk offline.
Great. Cool. You can drop, I guess, my name in there for the moment, and we'll see if we replace that with over time.
Cool. And it would be lovely if we could connect with someone from Python, because I really do want to know whether or not they would like to do __bomb__, as I expect. But anyway, cool. That was just sort of the quick touch point there we do.
Oh.
And
next up is Hank.
One quick thing we should probably note before we jump into that is we do run a pretty open agenda. And so if folks have things they would like to add to the agenda, because I know we've got folks from various other tools who are on the call as well, feel free to add yourselves.
And Jeff Schutt, I see you and also Jeff Hewitt on here, but the future agenda item for the SPDX intersection just says Jeff. So I think that's Jeff Schutt, but could you just confirm?
Yeah, that was me.
Awesome. Do you want to touch on that today or not?
We can. Don't recall if today is a tooling discussion or a standards discussion.
We skipped last one, so this should be a tech discussion, but we did skip last week. So yeah, overlap a little bit.
Wherever you'd like.
Okay. I think since we have the RATS folks here, I would love to start with that and try very hard to keep that conversation contained to about half an hour at most. If we then touch on SPDX, and that is a quick one, we can come back to RATS for the end of the call if there's nothing else. Sound good, Hank?
So I see that I got permissions.
Yep, go ahead and share.
Yeah, trying to. So the thing is, without preparations, it's very difficult always for me to find the thing I want to share. I assume it's this one. Bear with me if that's not the wrong window, not the correct window. Let me enlarge this. And it is, of course, not the correct window. Sure, why not? And so I have to stop sharing that one.
Holy tabs, man. That's amazing.
Yeah. No, this is my Chromium only. This is just 150 tabs. The 1,500 other tabs are in other. They're in the Brave because I'm a Brave one. So let me try to. There it is. Okay, that looks better. Yeah, this one I can actually full screen, and it's visible to you. Okay, here we go. Let me just do this. Okay, so now I can look at the camera at the same time while presenting, or doing with my other thing, the choop, choop, and that's actually working. Excellent. So hi, I'm Hank. Here now I'm coming over from the IETF. That's my contributor role there. As Eric, we were proponents in creating this working group. And why did we do that? There's a lot of technology out there that does trustworthiness proofs. The TCG basically branded that 25 years ago. TCPA, I think was it's called. Now it's TCG, and there's a lot of development now. Now you don't rely on HSMs anymore. You rely on a variety of things that can provide you with certain assertions about the trustworthiness of a device or a virtual thing, and in the end, what you really need are protocols. So actually, well, the best place to do protocols is the IETF. They are for the internet and the greater good. And so now we're talking about a working group in the IETF that's called RATS, the Remote Attestation Procedures Working Group. And I don't know, you might blame someone for that name, but I love the name RATS. So what is Remote Attestation Procedures about? In the end, you want to have secure interaction between peers. That's relatively obvious. I think you want to have your remote peer react and behave in an expected and appropriate manner. That means it's not compromised. Unfortunately, sometimes your remote peer is compromised, and even with malign intent. So now what you expect is that if some remote peer that is compromised, that will affect its behavior. And now we are here at GitBOM space, and so I assume that if a GitBOM creator, some remote peer that is in charge of creating GitBOMs, and if that's compromised, it might not create believable GitBOMs anymore. And the same is true for SBOMs or any kind of bombs, bomb. But as I understand it, a GitBOM is not an SBOM. It's just using the hashing algorithms of a GitBOM. It's for the will stuff. So I'm not going into that. You're basically at home here, and that's your space, so you know what this is about. But RATS is about providing evidence that is about trustworthiness of the things that create your GitBOMs. So that means creating evidence is very heterogeneous. I think there's a lot of systems out there that create GitBOMs, and they're all different. And so they will have to be in charge of creating evidence. But in the end, you're talking, and that's at the TLDR at the end of this page, you're talking to a relying party. So that one wants to have an attestation result. So RATS also does not only define how to produce evidence about this heterogeneous things that are your systems you talk to, but they're also about attestation results that you can present to the remote peer that wants to interact with you or your service. So RATS is basically an add-on. Everything that, for example, can use authentication can be augmented with remote attestation, and therefore some kind of trustworthiness into this interaction. And that also means not only the authentication can be augmented, but also documents provided by a system can be augmented. And now when we're talking documents, I think we are more on the BOM side again. And these documents can be augmented with notions of evidence and attestation results, asserting that they are produced by a trustworthy system. So the document producing system actually can believe it. So what we do in the end is that the consumer, the relying party, interacts with systems providing bombs like a GitBOM can be trusted. But trustworthy is an interesting term. So trustworthy is a system characteristic. So it's an inherent. You are trustworthy, you are not trustworthy, and there's a gray zone in between. Sure, okay, that's fine. But now you have to decide, and that's trust. So trustworthiness and trust are different things. System characteristics are trustworthiness, and I choose to trust these characteristics or not. That's my decision. Now I need some basis for that decision. And there are other documents out there like the RFC 4949 that tell you that a trusted system operates as expected and does not do anything else and such. So, but in the end, the important thing here is that the technology you use has to provide you with a basis for this decision to trust or don't to trust. And trustworthiness is therefore a little bit ephemeral. And the basis to establish this decision must be believable, and that's a lot of work. That's a lot of work because that mechanism, this quality for the trust decision is created in proofs, and these proofs are typically called attestation. Unfortunately, attestation means a lot of things. That's an overloaded term. So believable, trustworthy assertions are what we do at RATS, and unfortunately, what we're also doing here is we're creating bombs, and in the SBOM world, that's my second point here. An attestation actually is an endorsement. So we have a draft of the EO output here. I think everybody is aware of the executive order to improve the nation's cybersecurity in the US, and there's an output there. And if you click on that link here in the slide, you find an interesting draft version 2 provided by NIST, and that's all fine. And at the very bottom of the page, you find a link that's called terminology. And if you click on that link, you find suddenly the definition of attestation, which is just a statement about a decision of fulfillment of some requirements. And you could demonstrate that. So that's not actually trustworthiness. It's just you telling me or other people that what you provide is believable. But that's not a proof, that's an assertion, literally. So what is called an attestation in SBOM or in bombs in general actually is an endorsement of that message. And in RATS, we are trying to bootstrap from a hardware root of trust, and we will come into that, to some evidence that this was actually created in the way it's supposed to be. So the endorsement actually is through that root. And in SBOM, everything is an assertion that is an endorsement. So going to the next slide, what does mean attestation SBOM space? Well, I just already spoiled it. It's an endorsement, and there are actually 3 types of that. That's a first-party endorsement, and that's the producer of the software itself. And you have a second-party endorsement. Sorry, they call it attestation, but I'm having a hard time calling it attestation. So from my point of view of this world, this is endorsement. So then you have the purchaser of that, so the consumer of the software, and they can give an assertion about how this works, how this is trustworthy, and that's a second-party attestation. And then you have this general certification procedure out there, like FIPS or common criteria, and that's called a third-party attestation. Again, all of this are actually not RATS or remote attestations. From the RATS point of view, these are endorsement. And just keep in mind, in SBOM world, they're called also attestations, but from the RATS point of view, they're endorsements. So that's a significant cause for confusion. It took me quite a few months to figure out, literally, until I found this terminology. So an SBOM attestation is just a assertion coming from a trusted party, like a CA, some authority that tells you something. It's not a proof, it's a claim backed up by a CA or trust anchor. So why is this important? Because roots of trust and trust anchors could be turtles all the way down. Yeah, you have to root your trust somewhere, and that's an interesting conundrum. I'm putting this up here because otherwise it's absolutely even more confusing. I want to provide an understanding which end exists. So you have the root of trust, and that's inside the actor. For example, it's inside the attester that is the creator of your GitBOM. And then inside that creator of that GitBOM, it's an entity, it's a machine, it's a service, it's a bare metal thing, whatever. And there, it could be a TPM, right? So that's a root of trust. But that root of trust comes with an endorsement. It says the root of trust can't create evidence about itself. You have to believe that blindly because you have to trust into that function. But that trust now is given to you by the producer, by the manufacturer, and that's the endorsement. That's a trust anchor that's up in the sky in the bureaucracy. And between that creator of that root of trust and the root of trust in your system, there is a chain that's called the chain of trust. And typically that's a PKIX certification path, formerly known as a certificate chain.
So there's an interesting aspect here about chains of trust when GitBOM comes into the mix. And that is that because GitBOM calls for the embedding of an identifier, basically the GitBOM document identifier in the output artifact. Effectively, if you can get attestation of the artifact itself, then effectively you know what's being attested is that the thing that actually produced this artifact, this is in fact the GitBOM identification that it computed. Now, it may be consuming things for which you do not have attestations, but you essentially get the whole chain of trust all the way from the .o files all the way up to a Docker container are available as individual points in the chain of trust.
I love what you just said. Because yes, you're 90% correct.
Okay.
And
that's better than usual.
I think the words make a lot of sense. But the thing is that who gives trust to whom here is very important. So to turn this all the way down, terminate at the producer of the information that is the GitBOM. So and everything else is up the stairs. So Eva?
So for example, if there were a trusted build actor, that actor, when it built a binary and generated the GitBOM, would need some way to reflect its attestation. Here's what I built, that's the GitBOM, but also its own trustworthiness. Here's who I am.
Exactly.
And that's the part we've been talking about in some of our spec discussions of how do we embed the compiler or the build tool's own identity in this in a way that is verifiable. And we haven't pinned that down yet, but this is a great explanation for why we need to.
Absolutely.
Exactly.
And I guess the point I was getting at, though, is that we have places in which trust can occur all the way up the chain. So, for example, the compiler that compiles some CNH files into an .o file you may be involved in a process that produces an attestation of that .o file. That .o file may then be part of, say, the SDK for a chipset that gets handed as just the .o file off to the next step. So if I can have the attestation from the SDK vendor, I can pick up attesting from there. But every build step is only attesting what it found when it went to go do builds, if that makes sense.
I really understand what you are trying to say. I want to point at the three bottom items here at the slide. Mm-hmm. So the attester, which is the GitBOM creator, requires at least one root of trust to create evidence about its trustworthiness. And the attester requires someone outside, the builder of the attester or the creator of the software running on the attester or the trusted execution environment, so TPM, whatever, and requires a trust anchor. You believe in that the builder of the SBOM or the GitBOM is actually trustworthy. And now I will switch to the next slide because this. I deleted that slide. Oh, that's unfortunate. So okay, I was trying to put this down to 10 minutes. So the actual really problem here is there's a lot of confusion. Let's go with here. So there's a significant cause of confusion here because qualifying the term attestation is highly relevant. I understand that you said attested and attestation, but I don't know what this means because the very first highlighting here is it's attestation or is endorsement. Is a third party trying to tell you this is correct? or does the creator of the information where you get the information from is providing you with evidence that everything has occurred as expected to be?
I'll give I'll give two examples that illustrate the differences here and why it's important. If you pop back to the slide with the three levels, that one. In a hypothetical scenario where Microsoft is building software across a lot of different teams, the trust root might be Microsoft's signing certificate. And this is just as true for any other big company doing internal builds. And so there would be a first-party attestation coming from, say, the compiler team that says, we've compiled this thing. Here is the binary for the compiler or the build tool. That's trustworthy. And then another team might consume that, use it to build software that's relying on the second party. It's still internal, but it's a different team's. And so there's the same shared trust root for both of those, but it's a different team relying on the first team's trust. Now, translate this to open source development. And if I download the Rust compiler and I compile it myself, it's, even though I compiled it, it's missing, I'm suddenly a second party there. Unless I'm saying that I am the first party attesting the veracity of this particular instantiation of a Rust compiler. Do you trust my build of the Rust compiler versus Nell's build? You should trust Nell's better than mine. And does the Rust core team produce a signed Rust compiler with a trust anchor that represents the Rust core team's trustability? Then is something else in the Rust ecosystem built with the official compiler that becomes a second party attestation using it? We can map it in that way, but it definitely gets messy when one of the cultural norms in a lot of places is to just recompile it yourself and you lose that first party attestation. So Hank, is that terminology working for you as I talk about those two scenarios?
Yeah, so rebuilding it yourself is going into the reproducible build domain, of course.
Yes.
So
yes.
I'm not touching that domain because that in order to fling the poo, you have to touch the poo.
We do get into that space very quickly in GitBOM, because if I rebuild the Rust compiler and everything matches, the GitBOM output, the hash all match, even though I built it, it should in principle have the same trustworthiness as if Nell built it.
So yeah, but backing off though, Hank, because I think there's the distinction you were making between attestation and endorsement is attestation is some actual evidence that this is the way I say it is. Endorsement is me telling you I'm a trustworthy entity and I say it is so.
Exactly. So whatever here, the first party, second party, and third party attestation, you should, from my point of view, and I'm just a Reds guy, you should avoid substitution and substitute attestation with endorsement, actually. Because the system isn't telling you, the producer is telling you, the purchaser is telling you, or the certificator is telling you.
So, but there's a little nit in here for GitBOM that I think could be potentially very powerful, right? Okay. And it has to do with the granularity of what is being endorsed or attested, right? Because let's say I'm the linker, and I'm linking some .os into an executable. I, as the linker, either can provide you with an attestation or an endorsement, right? Either one, that says, yes, I took these .o files and I built this executable out of them. And the executable contains embedded in it the GitBOM ID that basically references those .o files. Now, each of those .o files also contain a GitBOM identifier in them. So even if somebody different was compiling them and producing their endorsement or attestation of those .o files, I can present that, and essentially what the linker is attesting is not that guy's endorsement of those .o files. The linker is just presenting those were exactly the .o files that I built in. Does that make sense?
The linker provides you with two things. It provides you with the exact thing it did, like I exactly use these .o files. And also it provides you with evidence that I'm actually that linker, I'm running on the system, I'm using Reds to tell you this. That's the evidence. And then both what it did and what it is are both remote attestation evidence. They are, I don't like the word attestation, I'm calling them evidence. And then from the outside now, you can check with endorsers and reference values providers. And then we'll come to that, there are more graphs. This is very text heavy at the beginning, the graphs will be at the end. So now you have all this information, but now you have to check that with the trust anchor. Check. This was signed with the turtles all down rule of trust. Okay, fine. Does this check out with the software that I expect to be linked in the .os? Okay, that's fine. The compiler or the linker actually is compliant with what I think it should be. Okay, now I might trust the output.
Yeah, but my underlying point is, because of the narrowness and scope of what evidence is being provided for, you can collect up first-party evidence all the way along the chain, even if those parties are completely different, because the linker is not attesting that the compiler did its job correctly. The linker is just attesting that these are the .o files that it linked.
The funny thing is that the actual definition of this so-called attestation is literally calling out, this is not attestation, it's self-attestation. Self-attestation is not a thing. It's literally admitting that you are not doing remote attestation. It's self-attestation.
No.
You're just claiming this by yourself.
Yeah. So time check. If you have more slides, let's rush through those.
Yeah, let's run through them.
Have more time for Q&A.
Yeah, that's Q&A later on. So turtles, and so there's an architecture here. So all this is happening to cater this one here. That's an important one, and I want to self-attestation is not a thing. Exactly, it's just a self-assertion. Thank you for the comment. And so but all this happens to help this guy here, the relaying party. The relaying party wants to just be sure that that one here, that's the GitBOM creator, is reliable and believable. And you need all these weird things here in between to actually do that in rats. There's an intermediate party that consumes all the complex details about the GitBOM creator and provides to you a digestible thing that's an attestation result. It's in the easiest and simplest golden scenario is a yes or no. So that's how this works in the end. And now let's strip this one here. So what the first thing that's happening is that the GitBOM creator provides evidence about itself, having a root of trust like a DICE or a TE or a TPM, a root of trust that it can be endorsed, and it provides this evidence signed due to that root of trust to the third party that's introduced here. That's a verifier. Secondly, the verifier consumes the trust anchor information. That's the endorser and the reference value provider, like how should this look like, how should the signature look like, and consumes all of that, and now makes policy decisions because someone owns this and there's a policy going into here. And in the end, that helps you to provide the relaying party with a simple, digestible attestation result. And this is where we do a lot of standardization at the model level, because we want to understand, is this a confidential thing? Is this a reliable thing? Is this a believable thing? So there are a lot of policies that can be in place here. You can make up whatever you want effectively to verify here. But the important thing is you can't just, as a relaying party, believe the attester. You need an intermediate party that you actually put your trust in, because it's closer to you. In this diagram, it's really closer to you. You have to put that signer into your trust anchor. And if you believe that signer, you can believe this signer. And that's the GitBOM creator. So you basically, you offload the burden of appraisal of all this evidence to this one here. And that's the RATS concept. You offload the burden of appraisal to a third party to trust you, to give you digestible attestation results that are easily consumed. And now these attestation results can be stapled to a GitBOM. Now, if you get a GitBOM and a attestation result and a notion where to check that with a verifier, that you may choose or not to choose to trust because it's trustworthy, you can infer transitively the trustworthiness of the attester, which is the GitBOM creator. And that's the benefit Rats would add to your
I think there may be something else interesting here, though, which is because, and this just gently touches on the reproducible build space, but it doesn't really go into it. But because I always have a GitBOM identifier, or I'm using Gitoids as the identifier for the artifact, if I have an artifact, not only can I go and pull its whole GitBOM tree, I could go pull from any number of sources what their evidence is that Git object ID came from some sort of thing. So it might be possible that I may have independent evidence to consider as I'm trying to decide whether I trust things. It is probably true that independent evidence is more trustworthy than singular evidence.
Yes, the more evidence you get about your tool chain, I want to say, or your pipeline, your build chain, the more evidence is presented to that from that chain to verifiers who trust, the more believable and the more higher level of assurance your GitBOMs get. And I'm just saying that you can staple evidence to GitBOMs, but evidence is very verbose. Your GitBOM builder can be anything. It can be a Raspberry Pi, it can be a cloud machine, it can be a quantum computer, whatever, right? There's a vastly different things, and the evidence how to describe how they look like is vastly complex. And this complexity can't be just resolved by the party that tries to trust someone. I mean, how should they? How should you trust 20 different banks for a transaction? How should you trust a multitude of GitBOM creators? So you offload that task to a verifier. And these verifiers now you can add to your own trust anchor store, on the relying party side. And when you get a attestation result, it says, yes, no, maybe, I don't know,
well,
like in the song.
One of the really nice things here is that you mentioned the evidence sometimes being verbose. So GitBOM intrinsically considers evidence to be metadata, right? So we have lots of different kinds of metadata that people are using that they're referring into the GitBOM from. So if your evidence just simply says, hey, this is the Git object ID of the thing about which this evidence is about, now you can correlate that evidence to the output of a build tool and its associated GitBOM.
Yeah, but the attester goes really all the way down with the turtle stack. It starts with the BIOS, the bootloader, the OS, the runtime system, the application is started, the tool chain that is now creating GitBOMs, the artifact producing system. All of that provides is measured. It's measured before it's executed. You start with a very believable thing that's a root, and you believe that root due to the endorser because it's built by ARM. Intel,
my only point was my only point was that you have a lot of freedom about how you want to present evidence because it doesn't go into the GitBOM, it references the GitBOM.
Yeah, exactly.
In the end, the evidence I think should even be abstracted. It should not actually be included in any GitBOM.
So Hank,
is the attestation result. Sorry.
To clarify, I think what Ed's point is that you might be missing the distinction here. GitBOM and SBOM are vastly different animals.
Yes.
A GitBOM is an artifact dependency graph. You can think of it really as the same file structure as what underlies Git. It's a Merkle tree of hashes and nothing more. So most of the evidence you're describing would fit in an SBOM or in some other format that you're working on. It is not going to fit in the GitBOM because the GitBOM is just a Merkle tree of hashes of files, and the tree structure itself represents the relationship between those files and steps in the build process. That's it.
That's excellent, because if it's a Merkle tree, it is really relating to anything that we are creating for supply chain security and integrity right now, because we are basically, we're calling this Merkle tree ledger, and it's a append-only structure.
The storage mechanisms are completely different. That's I know what you're talking about, a completely different thing.
Really?
Yes.
Are they? But
yeah,
you-
but Merkle trees.
Interesting.
Merkle trees are not necessarily ledgers, so that's something to keep in mind. So like Git turns it into a ledger, but the storage itself is not.
Git stores this Merkle tree as a collection of flat files on disk, for example. So that's a conversation to take offline.
You can
for how
serialize a ledger however you want. That's true. Okay, yeah, sure, of course.
So we're at 15 minutes. So I'm going to time check. Would folks find it more valuable? Awesome.
Just stuff. I will share the presentation afterwards with the group. So this is just a relatively outdated list of things. Sorry.
If you could drop a link in there or in the notes, I'd love to open this up to first a meta question. Would folks find it more valuable to discuss this for the last 15 minutes or jump over to the SPDX topic?
Yeah.
I'll just add, at some point, I'd like to return to the issue of hashes and their fragility and how we can deal with them. This is issue 11 in the tracker. It doesn't have to be today, but sometime soon.
I presume you mean their fragility over time.
General fragility. They're intentionally fragile. We like that they're fragile, but
I get your point. Yes, you shake it and you get a different result. Yes.
Right, but sometimes we might want to actually know what they were before they got broken.
Oh yeah, I know exactly what you're getting at. Yes.
Yeah. So.
Maybe a better conversation for the spec call. Do you think?
Yeah, I think so, and worth more time. So I've added that to the notes here. We'll just pull it up to the top for next time.
All right. Thanks for accommodating me.
Of course. The folks, we run a pretty conversational meeting at times when there's not a presentation. So if folks want to just go off mute, raise your hand. I realize if folks haven't been steeped in attestation terminology for a while, there might be a lot of digesting going on right now. I think a few of us have had a head start on this.
I'm very glad I read the Trusting Computing in the Cloud book before this presentation, because that provided a great primer.
I'm so glad. Yes, Hank, I've been running around convincing people to read Mike's book.
Okay, cool. Thank you. Mike provided a good overview. It's like the principal book from Campbell for PCPL. The one about the trust relationships from in the 90s. So Mike's book is basically the next iteration of that. Yeah. Mike, it's Mike Prosser, exactly. That's a new one. I think it's a worthwhile read. I will put into the chat the precedent to that you must unfortunately also read, and it's a harder read.
Editing the book was harder than reading it, I promise. Okay, so I'm not seeing a ton of questions popping up about that. So Jeff, do you want to give us some update on SPDX? I'm sorry, before that, and thank you so much, Hank, for all of that brain dump just now. I think it's going to help this group a lot.
Yeah, and we can have a follow-up, smaller, dissected and divide and conquer things, right? There was a lot to dump. Oh no, so I know that. Sorry.
Thank you.
Okay, thank you, Hank. Actually, Hank has been working in the SPDX working groups as well, so there's a nice overlap there. But this update was really within SPDX. There's what is called the defects working group, focusing on, hey, how do SBOMs relate to security vulnerability information, and what do we need to do to enable one to link an SBOM to an advisory or a GitBOM document or anything else you might want to relate to link to in terms of some sort of URL for security. And so there's a patch that we have gotten in place and a pull request that's out there that I can share with you all now, so that SPDX now can be compatible with GitBOM in version 2 of the spec. Version 2.3 is where we'll see this. The version 3 will be significant changes from version 2. So this is but a patch, and it is to basically add on to Annex F within the SPDX spec. And Annex F talks about the different types of external repositories that are out there and identifiers. And yes, it commingles identifiers and locators, and we're not going to solve that problem in this patch of version 2 of the spec. We are focused on solving it in version 3. So for now, this was really just, hey, heads up to this team that using SPDX version 2.3, you'll have the ability to link to a GitBOM identifier as an external identifier.
That's awesome.
I will put a couple links here in the chat.
Perfect. And feel free to edit them to add them to the notes as well.
Yeah, I had a short chat with Kate Stewart about some of the same topics. So and tried to capture what you were just describing in the notes doc, but probably didn't do a great job of that.
I'll take a look.
Awesome. One of the topics of discussion, I guess, in some of the side conversations I've had around SPDX 3 is whether or not, and it's the answers I've gotten so far are yes, that GitBOM's proposed file format could be a serialization format for SPDX 3, at least the minimum fields.
Interesting.
Yeah, I could perhaps see that as well. I think the more instructive way to use it in version 3 of the model will be, so the SPDX data is a set of metadata, and you want to resolve that metadata back to the software artifact. Hence, the GitBOM identifier is the way to do that. So in the SPDX 3.0 model, we have an artifact URI field, which is one way that you can resolve back to the software artifact. And so using the GitBOM in that field would be a good way to solve for that.
Interesting. Thoughts, questions, cool cat pictures?
Thank you, Hank, and that was amazing stuff.
Yeah, again, this is a lot. I understand that, and I think the confusion about the attestation and attesting to things, and to basically just endorse things, and that the evidence from the GitBOM creator is the actual remote attestation. That's a difficult concept to grasp, especially between all the groups that are working on this. And what I'm realizing is that this is the biggest problem, actually, I think. Sorry, yeah.
Oh, well, just so speaking of Mike's book, there's a point in it that's made that trust is also a function of time and potentially degrades over time. Do you see an attestation degrading over time? Like this was from 1 year ago versus, gotcha, cool.
Yeah.
Yes, so that's, okay, that's, we are 7 minutes to the top of the hour, but let's quickly diverge into Merkle trees again and ledgers. So if you write to a ledger, you can have a write receipt. You can prove that you wrote to a ledger, a Merkle tree, and you can get this receipt. You can validate it offline. Now, you want to prove that you wrote to that ledger, but you also want to prove that you wrote something else to ledger. You now do a read receipt. You prove that you read your own assertion, you wrote this, and you prove that you read your own assertion, that you disproved this and updated it. It's decaying. So now you create a read receipt with a very short lifespan, like of, I don't know, a week or something. The write receipt could last forever because it's an append-only ledger. but now you read something, and the countersigning could provide you with the capability of telling you, well, you know, for this week, I will tell you, I just disproved this. And the next week, I will also tell you I disapproved this. And I can do this over and over again without adding to the ledger, but using the service, maintaining the ledger. So yes, I think this decaying problem is also manageable with a Merkle tree, although the Merkle tree is this spam thing that retains all the spam forever if you put nonsense into it. But if you have a gateway function that's halfway sensible, and you do the read receipts, you can provide read receipts on a recurring basis without adding to the ledger, but still providing proofs that you said this is not okay anymore. And if you stop saying this is not okay anymore, maybe you're dead. Maybe your software, your company died or whatever. You sometimes people disappear, you know, and that happens. So, and companies disappear. So writing and reading to this ledger thing, I think are both valuable, viable things to do. And the reading and the proof of reading something has an astonishingly high value. And proving to you on a regular basis that you read this and this is still true is an important heartbeat. So I think that's a solution to the decaying trust problem. Yeah.
Thank you.
So one thing to add to that as well is I may have full trust in the actual tree and the data that was put into it, but the data that it represents itself may also decay in trust as well. And to give a concrete example, if I have 3 pieces of software that do the same task, one of them has a security scan from today, one has one from a year ago, and the third one has one from 10 years ago, which of these 3 are you going to trust? And so there's also some of the information there just naturally degrades over time, and eventually you hit a threshold as to when you no longer trust that value anymore, even though the actual values themselves didn't change. But over time, that attestation, even though you can prove that it happened through cryptographic means, the value of that data or of that piece of information ends up degrading over time.
That's the move towards shorter-lived certificates.
Exactly, and we actually want to take the same pattern, and I actually want to use this for things like Spire. Like, do I give this thing a cryptographic identity? And then part of that is, well, when was the last time I did a scan on the source code that's being deployed here? And so it ties into that exactly as was described in this model.
Yeah, so we're talking about expiration and certificates. And I would carefully voice the notion that with the current trend of the certificate validity being shorter and shorter, and the assertions you want to make being, I have to survive, I don't know, shelf lifetime and other things before they're sold, makes it really feasible to do a like something like a Merkle tree that has an indefinite lifetime until the algorithm breaks, and a very short lifetime that you can reassure people about the validity by yourself. So that's again the right in perpetual thing, like set in stone, and the read whenever in the frequency, however people need it, and reassure them that this is still true by the endorser. And that's a new thing. That's not a PKIX system. I am aware of that, and it's a controversial thing to discuss. But
there are several systems out there proposing a solution that sounds very much like that. There's more than one that I know of. So. Okay,
I'm very happy to hear that, because that is literally what we are going to standardize at the moment. Because we can't deal with this absolute lifetime for both worlds, for the writing world and the reading world. And that's an asymmetry that doesn't really work together with one thing.
We are unfortunately 1 minute to the hour, and I saw Elliot and Frederick with their hands up. So Elliot, if you have a quick comment.
I think Frederick was before me, actually.
Oh, sorry.
You please move forward. Mine was to get that point in before.
Okay. So all I was going to say is we should be careful in these discussions about, especially with certificates. It's good if they actually merely refer to the identity of one of the parties involved, but not include claims. If you start adding claims about like RATS claims in them, the RATS claims are going to expire long before the certificate will expire in many cases. And to try and reissue certificates based on RATS claims is, and forgive the use of this term, a rat hole.
Yeah, never do certificates for this at all. I know that DICE uses X509. I get that, but they're ephemeral. But in general, the PKIX system is not suitable for this, I would assume.
Yeah, by the way, the spiffy certificates I was mentioning before have a 1 hour expiration. So they're really short. They're close to ephemeral at that point. But I still agree, don't put the claims in there. That's not a good idea. But for other reasons, I can go into that later.
Awesome. Thank you all. Lovely conversation today. See you all in a week.
Thanks again for organizing it.
I guess I will join again, I assume.
You're always, it's an open meeting, Hank. You're certainly always welcome.
Please do, it's really fun.
Sure. Thank you. Bye-bye.